One more problem to do for this week coming out of section 2.5 in the textbook. We're given the polynomial f of x equals x cubed plus 12x squared plus 21x plus 10. And we're told to find all the zeros of the polynomial function, and then your author gives us just this very long list of things we could do. We could use the rational zeros theorem. We could use something called Descartes' rule of signs, which we actually haven't covered. We could possibly even use the graph of the polynomial shown by a graphing utility. All right, well, that's the way I like to go about it. But since we've talked about the rational roots theorem, let's use our graphing calculator to narrow down from that list. So p's and q's. The p's are the factors of this last constant term. So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10 go into 10. The q's are the things that go and divide evenly into the leading coefficient. So here just plus or minus 1. And the p over q's, well, it's the things I get when I divide the p's by the q's. Well, that's kind of boring here. We just get that first list. It's kind of the best case ever with the rational roots theorem. Well, if I didn't have any intuition, I didn't have a graphing utility, that would give me 1, 2, 3, 4, 5, 6, 7, 8 things to try. So let's try to narrow that down so I don't have to try all 8 things. So let's get this original function typed into our graphing calculator. So I have x to the third plus 12x squared plus 21x plus 10. All right, let's mash the graph button and see what happens. All right, well, I don't see a whole lot of the polynomial, but I see an interesting thing happen here and something way out here. So I think I can actually spot all 3 zeros. I think there's one out here at minus 10, but I shouldn't just take the graphing calculator's word for it. And I think there's a 0 at minus 2. And since we have a touch and turn around on a cross here, that has an even multiplicity, so it has to have a multiplicity of at least 2. Well, if I have 3 zeros, that means that would have to have a multiplicity of 2, because the multiplicities add up to the degree. All right, I'm going to pick that minus 1 to get started with. I think that minus 1 has a multiplicity of 2. But we'll just put minus 1 in the box and see if it really is a 0 or if I'm being misled by a graph. All right, so just going through our synthetic division here, that really is a 0, getting that nice happy remainder of 0. And that lets me start to factor. All right, well, I think I can factor that, right? I see how to factor, but I'm going to pretend I didn't. I want to show you something. So what I could do is I could imagine doing a synthetic division again with one of the other zeros. Now, I happen to know minus 1 has a multiplicity of 2, so I think minus 1 also has to go evenly into x squared plus 11x plus 10. So I'm going to do the synthetic division again, just for the heck of it. And again, I get a remainder of 0. I already have a factor of x plus 1. That would give me another factor of x plus 1. And then I'd have an x plus 10 left over. Found all of my zeros. Minus 1 and positive 10. And heck, I even found their multiplicities along the way. This one happens twice and that happens 1 time. Well, that's all the problems I wanted to do for the week. So there you go.